Hello guys, it's Kumar K, your favorite DSA teacher when it comes to solving hard, new, unseen and interesting DSA problems. So today we are going to solve the world's toughest lead code problem. Why it is called the world's toughest lead code problem? Because it was asked in a recent lead code contest where 40,000 people participated, but only 20 people could solve this problem. This is the lowest acceptance rate for any DSA problem on lead code in all the years till now. So my task is very simple. All I have to do is make sure that you understand the solution to this toughest problem ever. So, yeah, coming to me, I have worked at Media.net and Amazon as a software engineer. Despite being from a tier 4 college, I cracked those offers off campus few years back. And now I spend most of my time in guiding and training students and running some other ventures. Also, guys, if you are someone who is trying to improve their DSA skills, full stack development skills, system design skills, they want to crack hard unseen OA of top tech companies, want to improve their CP skills, want referrals of top 500 companies, we have a very best level program for those people. The link in the description is there, you guys can check it out. Now, going towards the problem, it requires the knowledge of prime factors, deep knowledge of greedy algorithms and how to create your own greedy algorithms constructively, and very, very deep knowledge of string and lexicographic nature. If you know those things, this problem can be easy for you, but in general, it's not that easy. That's why it's termed as world's toughest lead code problem. So, what is the easy version of the problem? The easy version of the problem is that you are given a t, and t can be anywhere from 1 to 10 raised to 14. T can be anywhere from 1 to 10 raised to 14. Okay, you have to find a number, smallest number whose product of digits mod t is equal to 0. So let's say t is equal to, okay, let's take a number like let's say 15. Now, how will you find out the smallest number whose product of digits is divisible by 15? The correct answer is 35. Why the answer is 35? Well, you can see that, right? That what is the product of the digits? It is 3 into 5, 15. And 15 is divisible by 15, right? So I hope you understood that doing brute force you can easily solve it, right? Start, initialize your answer as 1. Check, is 1 divisible by 15? No. Then check for 2, 3, 4, 5, 6. You will keep on getting big numbers, 14, 15. Then when you come to 35, check whatever number you currently have, check the product of its digits. For example, product of digits for 14 is 1 into 4, 4, etc. For 35, it's 3 into 5, 15, which is divisible by 15. So that's why that's the correct answer. But in the question given to us, the thing is that the number can be very, very large. Okay, the t can be very, very large. Okay, the t can be very, very large. So doing brute force is not efficient. We need some shortcut trick to know how to find the smallest number whose product of digits is divisible by t. The simple solution is do prime factorization. For example, let's say t is 256. What will be the prime factorization? I assume you know how to do prime factorization. Guys, in case you don't know how to do prime factorization, please do proper thorough research on how to find prime factors of a number. Okay, so if you do the prime factorization, it will come as a 2 raised to 2 raised to 5 is 32, right? 2 raised to 5 is 32, and if I multiply by 2 raised to 1, it becomes 64. Then one more time and one more time, it becomes 128, and then it becomes 256, right? So now what do we do? It is 2 raised to 8. It is 2 raised to 8, right? It is 2 raised to 8. So the solution is that you can simply make a string of 2 coming 8 times. And this is correct. This is divisible by t, right? Because you did the prime factorization. Now, whatever number of times the 2 is coming right there, its product is 256 only, which is divisible by 256. So problem is solved. Like this, you can do for many different cases, okay? For example, let's say t equal to 30. So you have to do prime factorization only using single digits, okay? 2, 3, 5, 7. Because you're only considering one digit products, right? So there are no other prime numbers apart from 2, 3, 5, 7. If you are considering only single digit numbers, right? So t equal to 30, what it will be? 2 into 15, which can be written as 2 into 3 into 5. 2 raised to 1, 3 raised to 1, 5 raised to 1. So you can say that, sir, answer is 235. Answer is 235. Now, why is the answer 235? Because you can see that you did the prime factorization and you sorted these numbers and you wrote them as it is. Now, for sure, their product will be divisible by 30. Okay, so I hope this much is clear to you. I hope you are enjoying the problem till here. You should be enjoying till here. Okay, now let me show you some more interesting cases. Okay, this one 24. It can be written as 2 raised to 3 multiplied by 3 raised to 1. This is the prime factorization. Then some people will say that, sir, this is the answer, right? Smallest number, right? No, actually. What you can do is that once you get the prime factorization, now you can club some numbers. You can club some numbers. Which numbers you can club, guys? These three twos can become an 8. And this 3 will remain as it is. Got it? 83 is much smaller than 2223. So I want you to create a function which immediately tells me the smallest number whose mod t will be 0. I want you to create that brilliant function, okay? So guys, I hope that each one of you understood that all you have to do is find the prime factorization, okay? In the form of 2 key power, 3 power, power of 5, power of 7. When you get these numbers, now try to merge them and try to make them smaller. That's the solution. You found the solution to the easiest version of world's toughest lead code problem. So, guys, what is the solution for the easy version? Easy version is that you are given a t which can be from 1 to 10 raised to 14. Find the smallest number whose product of digits is divisible by t. Obviously, no digit should be 0 in our answer, or else the product will become 0. We want a positive product which is divisible by t. Prime factorization of t I will do. Then I will put it through a minimum rearrangement function. It will, guys, club all the twos again and again, and make them 4 and 8. It will club all the three again and again, and it will try to make it 9 and 6. So let me explain this to you by a very nice example. Let's say t looks like this. T is a number whose prime factorization looks like this. So in normal form, 2 will be coming 6 times, then 3 will be coming 6 times, then 7 will be coming 2 times, right? You have sorted it so it looks small, but you can make it smaller. Can you make it smaller? Yes, you can. How can you make it smaller? 2 is coming 6 times, right? How can you club these 2's into another single digit number so that the length of the number decreases? Guys, I hope you understand that if the length of the number decreases, the number also decreases. Okay. I hope that you understand that basic simple thing. So, what you can do is that you can see those twos, right? You can club these three twos into an 8, club these three twos into an 8 as well. Okay. And coming to 3, 3 is coming 6 time, right? Two threes can become a single digit number 9. This also 9. This also 9. 7 cannot be reduced. because 7 into 7 is 49 and 49 is not a single digit number. So you can say that the final answer is only 2 times 8, 3 times 9 and 2 times 7, and sort it, what it becomes? 778899. Okay, so I hope you got the solution to the easy version till now. Okay, today I am having some health related issues. I'm having cold, so it's very difficult for me to record this video, but I'm doing it because the problem is so interesting and it will help you also a lot. Now, the basic thing is clear to you, right? If I give you any t in the range 1 to 10 raised to 14, you have now learned that you have to convert this into the prime factorization. Okay, power of 2 something, power of 3 something, power of 5 something, power of 7 something. Then what will you do? 5 and 7 cannot be changed, okay, but 2 and 3 you can club these powers. Okay, so keep on merging and clubbing the powers for 2 and powers of 3. Okay, make the 2 all 8 and all the 3 is 9, and keep on doing it greedily. Some a little bit of homework is there, also there for you. Try to do it. Actual problem is that you have to do the same thing, but your final answer should be greater than equal to the input number given. So basically, you are given a very big number. The length of that number can be as large as 10 raised to 5. You are given a t also. Now you have to find the answer, which is what? The products of the digits of that particular number should be divisible by t. I hope that much you understand, right? So that much you will do, but the main issue here is that your answer should be greater than equal to num. So that's what makes everything difficult. Okay, that's what make everything difficult here. Okay, so let's discuss it with some sample cases. So for example, let's say t equal to 256. T equal to 256. Okay, so let's assume t is equal to 256. Okay, and number is equal to 1 2 3 4. Now t is 256, right? So no matter how difficult this problem is, I will make sure that you understand. So it looks like what? It looks like 2 raised to 8, right? Which is 2 2 2 2 2 2 2 2, which is what? This can turn into 8, this can turn into 8, this can turn into 4. So the answer is 488. 488 is the smallest representation. But can you print 488 in the final answer? No. Why? Now the actual question is saying that whatever answer you are finding, na, it should be greater than the given input number. Okay. So 488 is not greater than 1234. So find a number which follows all the condition, which is the smallest, but it should be greater than equal to 1234. So what can you do here? You can just add a 1, right? 1488. And the product remains the same. Product is still divisible by t. Yes, sir. And everything is happening so nicely in this problem, right? So the thing is that you need to be very careful now. Okay, so what will be the solution now that we are given a t also and we are given a num also? Okay, we are given a t and we are given a very big number whose length can be as long as 10 is to 5. So first I will find the minimum answer. I know how to find the minimum answer by doing the prime factorization, then doing the clubbing. I find this minimum answer. If this minimum answer is greater than equal to num, num is also given in the input. If it is greater than equal to the num, well, this is the only answer. Simple. Nothing else to do. The only case we need to solve is that what should we do if the minimum answer is less than num? For example, t 256, num 1234. In this case, what happened? The minimum answer is coming as what? 488. But 488 is not greater than equal to num, and the question is saying get a number greater than this, which is valid. So here you add a 1 in the start because it does not change the product, and 1488. is bigger than this. But this is just one of the strategies mentioned here. There can be many strategies to solve this problem. So how will we do it is the thing we need to think about. Okay. So guys, what can we do? If the minimum answer is not getting satisfied with this, the simplest strategy is use the lexicographic nature of numbers. Okay. This is the number 1, 2, 3, 4, right? You want a number bigger than this. So what can you do? Either you can do the change at the first digit. At the first digit, let's say you use 2. Now whatever you use here does not matter. Does not matter, because if you write a 2 here, it has become greater than this. Okay. See the lexicographic deep nature. Okay. This is what I wanted to teach you, that if you change the first number, make it bigger. Now what number come here, even if you write here 111, does not matter, because if first digit is bigger than this has become bigger than this. That's what the question was asking, right? Bigger than the current nums, but still the smallest one. Okay. So notorious the question is. So now, either you can do that, or you can keep the first number as it is and change the second number. Or you can keep the first two numbers as it is and change the third number. Or you can keep the first three numbers as it is and change the last number. Which will be the best option? One option can be that, you change the first number itself and then some numbers is coming here. Another option is you change the, let's say, second number and then something is coming here. Another option is the first two numbers remain the same, you change something here and then the things are coming. The another option is first three numbers remain the same and you change something here. This is not the best option. This is also not the best option. I'm trying to show it visually to you. Okay. This is also not the best option. This is the best option. Why? Because the longest prefix is matching. Prefix means starting part. Starting part is matching the longest. It means this number will be greater than 1, 2, 3, 4, and it will be the closest to 1, 2, 3, 4. Okay. The thing is that first you calculate the minimum rearrangement, right? If it is already greater than num, then the answer is this only. We cannot make any smaller than that. But if not, simply make sure that you can at least match the first index. Okay. If yes, try to match the first two index and so on. Try to match the longest prefix. That's what the most interesting thing in the lexicographic problem, that you should try to match the longest prefix. If you try to match the longest prefix, the answer will be correct. The answer, the number will be bigger than the nums and also the closest to the nums. So y is the largest index, prefix index, which can match. Okay. So let's some examples. I will use some examples to show you how this works. Okay. So let's take an example. 9 or triple two. Okay. So guys, T is 256. This is nums. This is the problem only 20-30 people in the world could solve. See, you are now understanding its solution, how high you have reached, just by doing simple observations. So what can you do here? This is what, 2 raised to 8. Smallest representation is 488. So first I will try to put 488. Is 488 greater than this? No. So this will not work. Directly putting 488 does not work. Obviously, there is one simple solution, guys. If nothing works, you can always do this, right? 488 and just write ones until it becomes bigger. This is correct, na? 488, then 1, 1. This has become bigger than this, and smallest also, because you're adding 1 in the start. But can there be a better solution than this? If nothing works, obviously that is the answer. That's the corner case. But now, What can you do? Try to first make the first index matching. So in my final answer, if the first index matches, it's a great news. So let's say the 9 matches. Great news. Now, can you find with the remaining ammunition? Can you find a representation of numbers here which will be closest and will be able to beat this triple two? Yes, you can do that. It's easy, man. All you have to do is that this 222, right? And you have written a 9 here already. So, the number should be divisible by 8. So, this 9 you have written here, that's a great thing. Now, you can just write 488 here, right? And the problem solved. Correct. Done. Now, why it is correct? Think about it. First number is matching, so it gets closer to that number. Okay. So, 9488 is the correct answer. Now, there can be different simulations also. Try to match the first two numbers. That will be even a better answer than that. So, first two numbers are what? Try to match them. Let's say first two numbers should be equal. Like our answers first two digits should match. The larger the prefix matches, the better the answer becomes. I taught you that. So 9 and 2. Now this is a greedy homework for you. The homework is to figure out that whenever you write 9 2 here, you will use the representation given to you. Okay. 488. From 488, 1 2 is getting used. So now the representation we only require 288. Why? It was 4 into 8 into 8 now, but now 1 2 is getting used on the left hand side, so instead of this 4, now only 2 is there, right? 2 into 2 4, so 288. Can you put 288 in this much box? Can 288 be represented as two numbers? No, it cannot be represented. So first two numbers cannot be matched. If first two numbers cannot be matched, first three can also be not matched, first four can also be not matched. That's how simple it is, and that's how brilliant it is. Okay, so we have reached towards the solution. Okay, such a nice problem it is, right? Let's use some more brilliant cases for us ourselves, right? 2 3 9 9 9. Okay, now let's say t is 512, which is 2 raised to 9, which looks like 888. Okay, is triple eight able to is greater than equal to num? No, it is not greater than equal to num. Okay, I am teaching you many things, but no, please know that all the greedy analysis, logical homework, and the checking if the number is bigger or smaller, you have to do that optimizations. This problem is that difficult that I cannot explain all the small parts. I can only give you the bigger picture. Okay. Okay, I can only give you the bigger picture. That's it. Now, these things are clear to you. So triple eight is not beating. So in worst case, if nothing works, just add one more one. This is one of the possible solutions. But what can be the other solution? Okay, first let's try to match just one number in the final answer. So let's say in my final answer there is a 2 here. Now what will happen? 1 2 is already used. Always whenever you fix some left number, use whatever is given here and remove that from the required configuration, because the required configuration will become smaller. As it becomes smaller, the chances increases that it will be able to beat these guys. Okay, so this is very greedy and requires deep intuition. Now what will you do? Think about that. The thing is that now 1 2 has been used. Can you make one prefix matching? If you can make one prefix matching, then that is very good. You are able to find the answer. Then if you are able to make two matching, that's even better. So can you make one matching? For one matching, if you remove 1 2, it is 488. So guys, how will you write 488 here in the minimum form? In the minimum form, it will look like 1488. Right here, 1488. But 1488 is not bigger than this part. So what will you do? The greedy logic says that whatever is the remaining part, whatever is the remaining part. See, you wanted triple eight, but 1 2 got used here, so you are remaining with 488. Now you want to, what will be its minimum form? You want a 4 digit number, so you add a 1 here. I will say convert it to maximum form. Guys, what will be the maximum form? In maximum form, each one can be converted to a 9, right? Because it does not affect the actual product. It only increases the product, which still remains divisible by t. And each 2, you should make it 8. Each 3, you can make it, bigger, bigger, bigger. We want to make the max largest, make it 9. Something like that. Each 2 make it 8. Each 3 make it 9. And 5 7 and others cannot be changed, and each 4 also you can make it 8. Okay, so this one make it 9, this 4 you make it 8, so it is now 9 888 is the max form. Now write it here, 9 888. Is it able to beat this? Yes, it means one prefix can match. Ha ha ha, that's it. That's the most brilliant solution. One prefix can match. Guys, in this solution only, can you tell me if two prefix can match? Now guys, if one prefix is working, try for two prefix. This is working. Now try for two prefix. How will you try for two prefix? Two prefix means you are trying to have 2 3 in your answer. 2 and 3. Is it possible now? Let's see. If you use 2 and 3, 3 is not the, required in this composition, but 2 is getting used. So 488 we are left with it. Okay. We are left with 488. So 488 is the minimum form. But we will convert it to max form. Because if the max form is able to beat this, then yes, this configuration is also valid. So guys, what will be the max form of 488? 8 cannot be further increased. This cannot. 4 can become 8. So 888 is the max form, right? So let me write 888 there. Is 888 able to beat this? No, means two prefix is not working. Two prefix matching is not happening. Hence, three prefix will not happen. Four will also not. Only one prefix solution is there. So, guys, what is the overall sketch of the solution? That a t is given to you, a nums is given to you. Okay. If the minimum answer of this is already greater than equal to num, the problem has been solved. But if that's not the case, what you will do, start the prefix matching. Okay. So this is the, prefix matching, let's say. This is the number. Right means that that much prefix length is matching. So this is matching. Okay. This is matching. Okay. This is not matching. If one time it stops matching, it stops matching like this. Which is the largest prefix? Largest, this is 1 2, largest prefix is 2. Why? Because this is the last time when a right condition came. The two numbers, you are able to make sure that they are matching with the final answer which is going to come. The more numbers, the more starting numbers they match, the more probability is that this number will be the smallest number greater than equal to num, which is valid. Okay. So you find the largest prefix. Now guys, the question comes, sir, what to do after finding the largest prefix? Let's say I come to know that the largest prefix is 2. Now what will you do? Now how will you construct the answer? If you're able to do this, guys, the problem has been solved. So let's use the previous example only, where t was 512 and our current nums was, you know that, right? 23999. Okay, yeah. What was the largest prefix matching? 1. Basically only this much part can match. Okay, largest prefix matching is what? 1. So now next step of the solution, I know that the largest prefix matching is 1, so I will by default write here 2, because I know that the first number of the nums and my answer is going to match. Now what to do? What is the remaining? 512 can be represented as 888, right? But 1 2 got used, right? So it is 488. So what is the minimum form of this? 1 4 888. Sorry, 1 4 8 8. Okay, guys, which number can I use here? Can I use a 3 here? Think about that. Can I use a 3 here? No! If you were able to use a 3 here, then you would get a 2 prefix matching ना. अगर यहाँ पर 3 लिख पाते तो 2 3 प्रीफिक्स मैचिंग में आना चाहिए था, बट तुम्हारा तो लॉन्गेस्ट प्रीफिक्स 1 है, मतलब यहाँ पर कभी 3 डाल ही नहीं सकते. So you cannot use a 3 there, bro. I hope you understand why we cannot use a 3 there. I hope you understand why we cannot use a 3 there, okay? Because if you were able to use a 3 here, then this would be 2 prefix matching, but your algorithm said that only 1 prefix matching is possible. So now which numbers you can use here? Any number bigger than 3, because we want a number greater than equal to nums. Same is not allowed. So you can use a 4, 5, 6, 7, 8, 9. That's it. Try all these possibilities and the problem is solved. That's it, guys. So first, I will try to use a 4. See, whatever is the number after this one, na? 4, 5, 6, 7, 8, 9. I will try this. If this does not work, I will try 5, then 6, then 7, then 8. Someone will surely work because I know that prefix matching 1 is working. It means I have checked that there is some way so that this second part beats this part. I have checked it using the max form in the past. So now, but if you have to, you have to try 4, 5, 6, 7, 8, 9, right? Let's say 4 does not work, but 5 works. Do you need to check all these numbers? No, because 5 is the smallest one. We want the smallest one here, which is greater than 3. So let's try with 4. So what will you do? I put a 4 here randomly. So guys, if I put a 4 here randomly, what is my minimum configuration? 488. 4 will go from here. Only 88 is required now. So can I represent 88 here in the minimum form? What will be the minimum form of 88? 188. Problem solved. यू कैन राइट द मिनिमम फॉर्म हियर. वाई? बिकॉज जब तुम यहां पर 4 लिखते हो ना तो ये इस नंबर से बड़ा हो जाता है. नाउ देर इज नो बाउंडेशन ऑन वॉट यू आर राइटिंग हियर, बिकॉज एज सुन एज यू राइट अ नंबर, सी 23999, this is same, but as soon as I write a 4 here, now it does not matter what I write here. Even if I write all 1, still this number will be greater than this number. Okay, so once you put a 4 here, whatever is the remaining composition, 88, find the minimum composition of it for 3 digits and put it here and the problem is solved. Great. So many greedy observations, and guys, now the world's toughest lead code problem has been solved and I hope you understood the solution. There are many small homeworks you have to do that, and there are 5 6 greedy logics getting used here. You need to analyze them, how they work, why they work. That's it. And then guys, there is one more last thing which you need to do is that in the step 1, now you remember when you were trying to find the longest prefix matching, I said that I will put a 2 here, right? And then let's say, yeah, you put a 2 here and the composition was what, 888. So the remaining one is what, 488, because 2 got used here. Then you find its max form, right? Max form is what? First you find the min form. Min form is what? 1488. Max form will be what? 9888. But how will you know that if 9888 is bigger than this or not? This string can be very large, 10 raised to 5. You can use simple optimizations. Whatever this 9888 we have now, they will always be sorted like this. First there will be all nines, then eights, then sevens, then 6 5 4 3 2 till 1. So if you know the count of them, you can simply check if they are greater than or smaller than these numbers in just 10 iterations by directly traveling the ranges. Okay, so that small piece of optimization you will have to do. सी सीइंग फ्रॉम आइज इज वेरी सिंपल. ये 9888 इससे बड़ा है, देख के पता चल जाता है, बट कोड को बताने के लिए थोड़ा टाइम लगेगा क्योंकि कोड में 9888 ये इतना, ये 10 raised to 5 जितना बड़ा हो सकता है. तो चेकिंग फंक्शन बनाना पड़ेगा जो एक झटके में ओ ऑफ 10 में चेक कर ले. दैट्स इट. So I hope you were able to understand all these things, and guys, thank you for watching this video. Hope it makes you very very strong. With the name of God, Ram Ram.